So let's talk about some properties of graphs that we can describe, starting with the idea of increasing, decreasing. So when describing increasing and decreasing, we're focusing on our output values or our y-coordinates, and it's as we're moving from the left to the right. So this first scenario here, what we could see is if we're traveling along this and we just kind of grab some coordinates, well, with each of those coordinates, if I map where I'm landing on the y-axis, they're getting larger and larger. So because that's going upward, or if you even think in terms of height here, the height of each of those from the x-axis is growing. So because it's getting higher up as we're reading from left to right, this would be a graph that is increasing. Similarly, it could look like that here, where maybe our first points look like they're about the same height, but then it would be going up and up and up. And with that, as we're reading from left to right, because we're going upward, that would also be increasing. Now here, again, reading left to right, here the heights between the x-axis and these points would be going downward. Or if I was plotting these on the y-axis, as I'm moving to the right, they're getting lower and lower. I'm getting closer to the x-axis. So reading left to right, this is going downward. So with that, this would be decreasing. And similar idea here of reading left to right and just kind of tracking along. Those points would be getting lower and lower on the y-axis, and with that, this would also be decreasing. So, when we describe increasing and decreasing on graphs, what we're going to do is describe it in interval notation. So, I'm going to ignore those maximums and minimums for just a moment here so that we can kind of stay focused on increasing, decreasing. So if I'm reading left to right, so what I'm going to do is start with this arrow down here in the lower left, and what I could see is if I'm traveling along this, I'm going upward and upward and upward until I hit that peak right there. And after that peak, what's going to happen is my y values are going to start decreasing, 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 decreasing until they hit a lowest point there. And then I switch over back to increasing and increasing. Again, I'm thinking about the y coordinates or the height of my graph as I'm moving to the right. So like here we're at 6, there's like a 7.3, here's an 8. So those y values were getting larger, but then when I move over here, it's like I start at 8, and then I'll be at 7, and then I'll be at 6. So those y values are decreasing. So if I wanted to describe intervals of increasing and decreasing, so increasing, I have the arrow there, so it's like all the way out to negative infinity, or rather from negative infinity. Our function is increasing until I reach x equals 2. So I'm using the x values to describe my interval here. So I'm using that 2 there, and another cutoff is going to be 6, and then out here to the left is negative infinity, and to the right is positive infinity. Now, in terms of brackets, with increasing, decreasing, we'll always be using just parentheses. You won't see square brackets. And that's because at these turning points, it's neither increasing nor decreasing. And how I like to think of this is like if you throw a ball into the air, it's going up and up and up. And then there's this moment where it hangs. It just stays still, and then it starts decreasing. And that moment where it's hanging, where it isn't increasing or decreasing, that's this kind of turning point. And with that, at these turning points, it won't be part of the increasing interval. It also won't be part of the decreasing interval because it's doing neither there technically. Okay, so that's our first part of the interval, but then we have the second interval starting at 6. Again, I'm using parentheses because we're not going to include that 6. And then we're going to go off to positive infinity. And then how I would describe the interval for decreasing. It's trapped between 2 and 6, and again, only parentheses because at 2 and 6, it's not increasing nor decreasing. Okay, so that's how we can write our intervals and see it from a graph for increasing, decreasing. Now let's talk about local maximums and local minimums and absolute maximums and absolute minimums. So local minimums and maximums will occur at these kind of, I call them peaks and valleys of our graph. So as I'm going along, it'll occur at these turning points, which I marked here. So like here's a turning point and here's a turning point. So why we're using the word local is because we're thinking in a very zoomed in sense. It's like if I zoom in, this looks like the largest point on the graph. And then if I'm down here, this looks like the lowest point on the graph. So local means it's kind of zoomed in just for that region. What's the largest value? So we'll describe these with coordinates. So we have a local maximum, and that is occurring at the coordinate 2, 8. Now we can have more than one local maximum because I could have a graph that does something like this. And if I wanted to show each of the local maximums, this would be one, this would be one, this would be one, and that would do it. So each of those points would be local maximums because they're creating this peak within a short region around it. So we could list multiple coordinates for that scenario. Same idea with local minimums. So that's going to be the coordinate 6, 4. And there could be multiples of those. So let's say I use a red dot for a local minimum. It would be anywhere that we're hitting kind of those valleys there. So that's a low point, another low point, another low point. Now notice with this one, I put these kind of end points here. Those would not be local minimums or maximums. That would, since we can't see what's happening to the left or the right of them, we don't know if that's the smallest value. So that's what's happening on a local level. Absolute maximums and minimums are the absolute largest and the absolute smallest value. Now with our graph here, because of those arrows at the end, we don't have absolute maximums or minimums here. That wouldn't be defined. So no absolute minimums or maximums because we go off to infinity. But like with this graph that I drew down here, where it's kind of finite, it's stuck between 2 points, my absolute maximum would be the absolutely tallest value. So that coordinate right there would be my absolute maximum. And then my absolute minimum would be the absolute smallest value, which would be right here. Now for absolute minimums and maximums, those end points, the beginning and end of the graph, could be our values. It's just looking at the graph. What's the absolute highest value? What's the absolute lowest value? So there are some new definitions for us. My little word of warning here is being careful with the notation. So something to keep in mind is that when we're describing increasing, decreasing, we're using intervals of x values. And when we're describing local minimums and maximums, we're using xy coordinates. All these parentheses can sometimes look a bit confusing, and it's important to know the context of what we're describing. So here it's just where x is beginning and ending for these intervals. So with that, we're using interval notation. With local minimums and maximums, these are going to be coordinates on our graph. So with that, it's an x and y coordinate that we're describing.